What if the universe is not a machine, not a physical structure, not a collection of particles floating through empty space, but a computation? What if reality itself is the output of a cosmic quantum computer that has been running since the birth of time? Today we explore a radical idea in modern physics and information theory. The universe might not just contain information, it might be information. The laws of physics might not describe what the universe is made of, but how the universe processes data. In this view, matter, energy, space, time, particles, fields, everything emerges from a deeper level where the fundamental currency is information, not atoms, not strings, bits. Or, in the quantum world, qubits. If this sounds far-fetched, remember this. Some of the brightest minds in physics believe it. John Archibald Wheeler, the physicist who coined the term black hole, famously said, "It from bit," meaning physical reality, it, arises from binary information, bit. But why would physicists take such an idea seriously? Let's start from the beginning, literally. At the instant of the Big Bang, the universe wasn't a hot ball of matter. It was a state of maximum information density. Everything that would ever exist was encoded in patterns of energy and quantum fields. There were no atoms yet, no galaxies, no space or time as you understand it. Only information evolving according to fundamental rules. Rules that we now call the laws of physics. And here's the key idea. Laws of physics look exactly like computational rules. They take an input state of the universe and compute the next state, over and over, billions of times per second, just like a program. But unlike a classical computer, the universe doesn't compute using zeros and ones. It computes using quantum states, superpositions, entanglements, probabilities. This is what gives reality its richness, its unpredictability, its complexity. Consider the double-slit experiment. A single particle seems to pass through two slits at once, interfering with itself. This behavior isn't random. It follows precise mathematical rules. Rules that resemble the evolution of quantum information. The universe doesn't decide where the particle is until it is measured, until information is extracted. In a quantum computer, a qubit behaves the same way. Not zero, not one, but both at once. A probability distribution, a wave of possibilities. Reality isn't determined until a measurement collapses the state. Now, consider black holes. In the 1970s, scientists discovered something shocking. Black holes store information. The amount of information is proportional not to their volume, but to the surface area of their event horizon. This led to the holographic principle, which states that the entire 3D universe might be encoded on a 2D boundary, like a cosmic hard drive storing reality as data. What you experience as space, as matter, as movement, might be a decoded projection of information written on a surface beyond your perception. That's not metaphor. It's one of the most mathematically supported ideas in theoretical physics. And here's the twist. If the universe is a hologram, then reality is essentially a rendering process, like a computer generating a 3D world from 2D data. But let's go deeper. If the universe behaves like a quantum computer, could it actually be one? To answer that, we need to understand what computation is. A computation is any process that transforms information according to rules. That's it. And the universe does that constantly. Every particle interaction is an information update. Every field fluctuation is a computation. Every thermodynamic process is a calculation of probabilities. Every chemical reaction is a processing of states. Even your thoughts are computations happening inside a biological neural network. The entire universe is a self-updating system driven by information. But why quantum? Because quantum computation is exponentially more powerful than classical computation. A classical bit can be either 0 or 1. A qubit can be both simultaneously. And when qubits become entangled, the computational power grows beyond anything imaginable. If the universe were classical, it could never store or process enough information to simulate itself. But a quantum universe can contain and compute its own structure. But here's a deeper question. If the universe is computing reality, what is it computing toward? What is the output? Some physicists think the output is simply evolution. of stars, of galaxies, of life, of consciousness. Others believe the universe is computing its own future paths, exploring all possible states. Some even think the universe is optimizing itself for complexity because information-rich structures tend to survive longer. But the most radical idea is this: the universe is computing itself for no purpose at all. Reality is simply what happens when quantum information obeys mathematical rules. There is no programmer, no designer, no user. The universe is both the computer and the computation, both the system and the logic, both the hardware and the software, and you are a subprocess running within it. Your thoughts, your memories, your identity, they are not floating in space. They are patterns of information processed inside a biological quantum system, the brain, embedded inside a larger quantum system, the universe. This means something profound. Consciousness itself might be part of the universe's computation. When you observe reality, you create information. You collapse quantum states. You feed data back into the universal computation. In this view, consciousness is not an accident. It is an emergent informational process. It arises naturally in complex systems because the universe is structured to generate complexity. In this sense, consciousness is the universe becoming aware of itself. But here's the most mind-bending part. If the universe is a quantum computer, then reality might not be continuous. It could be pixelated, quantized, discrete. The smallest units of space, time, and energy might be bits of information. Space-time might be a computational grid. Movement might be the updating of data across that grid. The speed of light might be the processing speed of the universe. The Planck constant might be the smallest unit of action in the cosmic computation. And the laws of physics might be the operating system. But is there evidence for this? Yes. Quantum gravity research suggests space-time emerges from entangled networks. The universe behaves like a massive information processor. Simulation models of physics reproduce reality with surprising accuracy. And thermodynamics, once about heat, now looks like pure information theory. Even entropy isn't disorder, it's missing information. If the universe is computing, entropy is simply the cost of losing information during computation. But the deepest clue of all comes from quantum error correction. Physicists discovered that the universe protects certain quantum states from collapsing, exactly like a quantum computer, stabilizing data to prevent errors. The universe acts like it is maintaining coherence, preserving the fidelity of information, preventing decoherence in structured ways. Why would the universe do that, unless the universe is fundamentally processing information? If that's true, then your reality, your body, your memories, your experiences, are all part of an unimaginably vast computation. You are not separate from the universe. You are a dynamic pattern within its information flow. So, what does this mean for you? It means the universe is not cold, random machinery. It means your existence is not meaningless. It means your life is woven into the deepest structure of reality. You are a momentary expression of cosmic information, a temporary algorithm running in the universal quantum computer. And the choices you make, the observations you perform, feed back into that computation. Your consciousness participates in reality's evolution. The universe computes you, and you compute the universe. Let's discuss. This is Veritas Labs, where truth is tested.